Okay, so the first thing we want to do working with slope-intercept form, trying to solve for a line, it's giving us an additional coordinate. First thing we want to is basically we want to identify slope. What is our slope? All right, and in this case, they gave us the information that a line is perpendicular to a slope-intercept form of -7/6, x minus 3. Now I know perpendicular, if my slope is -7/6, then actually I'm going to flip and change the sign. Flip and change the sign. That's called a negative reciprocal. Negative reciprocal. So once I've identified my slope and I see that I have a coordinate, I go to my handy point slope form. It's my go-to. And I'll plug in my information. Y minus, be careful, these are negatives, -7 is equal to, I'm not going to use -7/6 as my slope. I'm going to use 6/7 as my slope. The reason for that is that this is the perpendicular slope to that, which is the negative reciprocal, yeah. Let's take a look at changing some of the signs. Y plus 7, this became a positive. Let's look at distributing this. Slope 6/7x plus a 30/7. How did I get 30/7? I did 6/7 times 5/1. I multiply across 30/7. Now we want to get y by ourselves. We want to establish a slope-intercept form here. Subtract 7. Subtract 7. We're going to have to do some common denominator here. 30/7 minus, now 7 times 7 is 49. And then if this is a positive and this is a negative, I actually want to find the difference. The bigger number is negative, so I'll say -19/7. So my slope-intercept form of this is going to be y is equal to 6/7x, my perpendicular slope, minus a 19/7. Now in some cases, here's my slope-intercept form. I could graph this because it gives me a y-intercept, it gives me a slope. But sometimes we'll be asked for standard form. The ax plus by equals c. We'll be asked for standard form. Now in order to do that, you have to do a couple things. One, you have to get the x and y on the same side. So what I'm going to do is I'm going to move the 6/7x. In order to do that, I have to subtract from the positive. I basically have to do an inverse movement of subtracting from both sides. And I get a negative 6/7x plus y is equal to negative 19/7. Now standard form, you have to consider a couple things. One, it does not have fractions. And usually the x or x coefficient, so this number in front of x, is going to be positive. This is a funny rule you got to pay attention to, that the x usually will be positive, okay? So let's do a couple things. One, I should have gave myself a little bit more space here. Let's multiply this whole equation by a 7. Now the reason I'm going to do that is because if I multiply by 7, I can actually eliminate the fractions. Think about it. Let me just multiply by 7 over here. If I did negative 6/7 times 7, I can cross reduce, and this becomes just negative 6. That's why I'm multiplying by the 7 here. So if I do negative 6 over 7x times 7, it's just going to become negative 6x. These two terms here cancel each other out. Now, I don't have anything under the y, so this will multiply plus 7y. And then again, these two multiplying by 7 will cancel out. This 7 equals negative 19. I have to be careful. I have a negative coefficient in front of my x, so I'll change all signs, and we'll call it plus, minus, plus. I'm changing the signs here. Plus 6x minus 7y equals plus 19. And this would be my standard form. And I kind of did a different color with the signs here to show you that we did a change in sign there.